Imagine standing in one of the driest landscapes in South Asia. A land of scorching heat, rolling dust storms, and cracked earth stretching to the horizon. A place where water is precious, where rivers appear only with the rains, and disappear just as quickly. Now imagine something impossible. Imagine this same land. Green, alive, dense forests lining a vast river valley, wildlife everywhere, fertile plains spreading for miles, settlements thriving along flowing water, and cutting through it all, a massive river system, powerful, life-giving, ancient, a river so important that people sang about it, worshipped it, called it sacred. One of the oldest surviving texts in human history praised this river as mighty, unstoppable, divine. Its name, Saraswati. But here is the mystery. If Saraswati was real, where did it go? Because when we open a modern map of India, there is no giant Saraswati River, no great Himalayan river crossing Rajasthan, no massive waterway flowing into the Arabian Sea. Nothing. Only dry channels, seasonal streams, and desert. So what happened? Was Saraswati simply mythology? A poetic river that never truly existed? Or did one of South Asia's greatest rivers actually vanish? Erased by tectonic shifts, changing climate? And if it disappeared, how does a river die? Because rivers do not simply vanish. To solve one of the greatest geological mysteries of the Indian subcontinent. This is the science of the lost Saraswati. To understand Saraswati, we start with the oldest clues we have. Ancient literature. In the Rig Veda, Saraswati is not described as a small stream. It is described as powerful, abundant, a river that gives life. One hymn calls it the best of mothers, the best of rivers, the best of goddesses. Now scientifically, we have to be careful. Ancient texts are not geological maps. They are cultural memory, because northwest India contains something very strange. Stretching through Haryana, across Rajasthan, and into Pakistan, lies a giant dry river corridor known as the Ghaggar-Hakra Paleochannel. And it is enormous, far too large for the small seasonal rivers that occupy parts of it today. That is our first big clue. In geomorphology, small rivers do not carve giant valleys. Tiny monsoon streams cannot build massive alluvial corridors tens of kilometers wide. That would be like finding a bicycle parked inside an aircraft hangar and claiming the bicycle built the hangar. Impossible. Something much larger once flowed here. And then archaeologists found something even more extraordinary. Hundreds of Harappan settlements, part of the Indus Valley civilization, clustered along this dry river corridor, along a ghost river. That tells us one simple thing. Water once existed here. And not a little water. A lot of it. Now the mystery becomes much bigger. What river once flowed here, and why did it disappear? To answer that, scientists stopped looking at old texts and started looking from space. Using remote sensing, multispectral imaging, radar mapping, and digital elevation models, scientists scanned northwest India in remarkable detail, and beneath the sands of the Thar Desert, they found something astonishing. Ancient river highways, buried channels, wide, continuous. These are called paleochannels. Fossil river systems preserved in sediment, geological fingerprints of rivers long gone. And one thing stood out immediately. The Ghaggar-Hakra Paleochannel is massively oversized compared to the modern Ghaggar River. In geology, this is called an underfit river, a small river flowing inside a valley carved by a much larger river. And underfit rivers usually mean one thing. The river system changed dramatically. Its discharge collapsed. Its tributaries were lost. Its drainage was rerouted. Or another river once flowed there. Then geologists looked upstream and found two major suspects. To the west, the Sutlej. To the east, the Yamuna. Today, the Sutlej joins the Indus system. The Yamuna joins the Ganga system. But rivers are not fixed forever. Over geological time, they migrate. They jump channels. They get captured. They avulse across floodplains. They reorganize entire landscapes. And that led scientists to a bold idea. What if one, or both, once fed the Ganga-Hakra system? If true, everything suddenly makes sense. The oversized channel, the settlements, the ancient descriptions of a mighty river, the ghost river beneath the desert. But ideas are cheap. Science needs evidence. And geologists asked one brilliant question. Where did the sand come from? Because sand remembers. Minerals carry chemical fingerprints, isotopic signatures, radioactive clocks, tiny zircon crystals, preserving stories hundreds of millions, even billions, of years old. And those grains were about to reveal the truth. How do you identify a river that died thousands of years ago? You interrogate what it left behind. Its sediment. Because rivers are transport machines. They grind mountains into grains, carry those grains across continents, and quietly deposit clues downstream. Every mountain range leaves its own signature, which means, if a powerful Himalayan river once flowed through the Ganga-Hakra corridor, the sediments should know. And scientists went looking. One of the most powerful tools they used is called detrital zircon uranium lead dating. It sounds technical, but the idea is beautiful. Tiny zircon crystals act like geological time capsules. They form deep inside igneous and metamorphic rocks, and preserve uranium atoms inside their crystal structure, over immense spans of time. That uranium slowly decays into lead at a known rate. That makes zircon an incredibly precise natural clock. Measure the uranium to lead ratio, and you can determine when that crystal formed. And because different source regions produce zircons of different ages, you can trace sediment back to its birthplace. This is geology doing forensic science. And the results were extraordinary. Some sediments in the Ganga-Hakra basin carry zircon age signatures that closely match material derived from the Sutlej River catchment. That is a major clue. Because the Sutlej is no small river. It is a major Himalayan system, fed by uplift, glacial melt, and immense erosional power. If Sutlej-derived sediments are present in Ganga-Hakra deposits, then at some point in geological history, water, sediment, or distributary flow from the Sutlej likely entered this corridor. That supports the idea that a much larger river system once existed here. But then, science complicates the story. Timing changes everything. Some studies suggest the Sutlej may have shifted westward long before the mature Harappan civilization flourished, possibly in the late Pleistocene or early Holocene. And if that is true, then by the Bronze Age, the Great Himalayan fed phase may already have ended. That changes the picture dramatically. Chemistry added another layer. Scientists analyzed strontium isotopes and neodymium isotopes, preserved in river sediments. Why does that matter? Because rocks carry isotopic fingerprints. Young Himalayan rocks have one signature. Ancient Indian cratonic rocks have another. Siwalic sediments have their own identity, which means sediment can be traced home. And what scientists found was complexity. Some deposits show strong Himalayan affinity. Others point to local sediment sources. Others appear to be recycled older alluvium. Ancient sediment eroded and deposited again. Translation: this was never one simple river with one simple story. It was a shifting fluvial network. Dynamic. Restless. Changing course across millennia. Capturing tributaries. Rebuilding itself again and again. Not myth. Not a single clean river. But a living drainage system. Constantly evolving. And to understand how it faded, We need to talk about rivers stealing rivers. One of the strangest things in geomorphology is that rivers can rob each other. Literally. This process is called river capture. Imagine one river cutting aggressively upstream, eroding headward, deepening its valley, extending farther and farther into nearby terrain, until one day, it intercepts another river's flow and steals it. Suddenly, river valleys dry, channels shrink, and evidence suggests that is exactly what happened here. So, what was Saraswati? The most scientifically balanced answer is this. It was probably either pure myth. Reality is more complex and far more fascinating. What ancient people may have remembered was a real river system occupying the Gagar-Hakra corridor. A system that changed dramatically through time. At certain phases, it likely received major Himalayan contributions, especially from paleochannels linked to the Sutlej. Then over thousands of years, river capture, tectonic reorganization, and climatic drying slowly dismantled it. Not suddenly, gradually, a mighty river system, reduced to seasonal remnants, and buried channels beneath desert sands. A river turned ghost. And yet, its scars remain visible from space. Its sediments still preserve memory. Its ancient floodplains still shape the land and geology. Quietly,